Welcome to another video from Cloud Linux. At Cloud Linux, we always try to get our students to develop a deeper understanding of the math concepts. Some of the reasons why is because we want students to go beyond mimicking what the tutor is doing and then practicing similar types of problems uh, to learn math. We think we have to go beyond that in math education and help them develop critical thinking skills that help them solve problems that they have not seen before and to apply their knowledge in problems that are not straightforward. So in this video, I have chosen the topic simple and compound interest. So I will illustrate how we use simulations. Geogebra is a tool that we love at Cloud Linux because we can develop our own models depending on the type of topics, and we also use existing resources that we think are really useful. So here's one such model that we've created at Cloud Linux, and I'll walk you through what we usually do as tutors to help students understand what simple interest and compound interest is. So first things first is we usually get the students to tell what they already know about simple and compound interest. And typically, let's say 90% or more than that, would say that they do know what compound interest and simple interest is, but they can't put it into words. What they can is really effectively solve problems, calculations, do the calculation part because they have memorized formulas, they've applied it over and over again, they've mimicked problems that have been done by other tutors or at school, and they think they're confident with it. So this model uh, will test where they're at, whether they do have that conceptual understanding that we are looking for. So, right, so this is really simple. We would share this link with the student. They get to change the numbers, look what happens. So first things, we would ask them to set a certain number. So here I'll set 20,000 for our starting balance. I'll set the interest rate at 15, and then, okay, we'll start things off. So you can get the student to look at what's going on. We'll put it to 5 years and ask questions like, what's the 3,000? Where's that from? How's that getting added? And what's happening to the balance? And so students will be able to come up with answers like, okay, that's 15%. They might have to do some calculations and then see how simple interest works. So this part, most of the students who've already done interest calculations can figure out quite easily. And then you can show them that, let's say, if you were to wait for 6 years and pull out the interest, you'd have collected 18,000 interest apart from what you started with 20,000. That's pretty straightforward. Now, you want to pose this question, right? Let's say, what will happen if you decided to withdraw the interest that the bank gives you each year? You decide to withdraw. What's the different thing that would happen? Will it be the same? Will it be a bad thing for me or a good thing for me? Will the banks like it? Will they not? How will that go? Let them think for it before they try simulating it. So you're not looking for the right answer. You're not looking to explain. You just want their feedback, what they think. Because in a simulation, the idea is it's experimentation. It's exploring stuff. And it's not like you're giving all the instructions and telling them do this, do this, do this, and telling them this is what it is, this is what it is, right? It's about exploring. So just pose the question and get their feedback. That's all you want, right? And so then you start, let's put this option over here. And now you want to show them what happens every year. So you can see 3,000, 3,000 you're pulling out from the bank every year, and you collect it to your wallet. And so the student should soon enough see that there's nothing different, right? And if you were to ask the student, if you were an investor, what would you do? Would you withdraw the interest every year, or would you just wait for 6 years and collect it afterwards? What's best? So students will argue both ways. They'll say, some students will say, wait, why do I have to wait for 6 years? I could take the money, that's no difference. I still get 18,000, but I don't have to wait for 6 years. I could spend it whenever I want. And so that's great for me. And there's no one important thing is that there's no incentive for me to keep the money in my bank, right? Because why do I have to keep this in my bank? Why can't you just get it to my wallet? There's no incentive, there's no reward for me to do so. So then you let them think from the bank's perspective. Will they like this? Will they like you to withdraw? Then, maybe you could contribute and say, banks really want you to keep the money in their accounts without withdrawing. So now you propose the idea. That's where compound interest comes into play. And now you get them to think. Okay, so you propose the idea that that's why compound interest is a model that banks use, and let's see how it works. So we just do not change the starting balance, keep the interest rate, and we are going to compare, and you get the students to compare. So you again show them what's going on. Now you try to compare it what happened with simple interest. So students will soon enough see that, instead of 3,000 every year, now it's increasing. Okay, some students who are already familiar with the equations would quickly go to their calculators, figure things out, and quickly find out that this is what's going on. And it's increasing because, the balance is also increasing, and you're not finding 15% of your starting balance, but rather once you collect more and more on your bank, the more interest you gain, because the interest is collected on your latest balance. So that idea some of the students will be able to grasp very quickly, but for some other students, a little bit of guidance. You can give them some direction and ask them, how did 3,450 come from? If that was your latest balance, could you find what 15% of that is? And then gives them some direction. Or even ask them to apply the formulas and see how that works. Right? To confirm that this indeed, after 2 years, you'd have 26,450 in your bank, and so on. Right, so the interesting thing is they should see that this is really nice. It's better than simple interest because you're earning more. Right? You're earning 26,261 compared to 18,000 interest. But the beautiful part here is now you want to ask students what will happen here if I decide to withdraw every year. All right, give them some time. Like I said, this is about exploring. Give them some time to give their feedback. And then we usually show what's going on. And maybe if students did not have a deeper understanding or the right understanding of how compounding works, they'll be surprised to see what's going on. So they'll be surprised, but then soon enough, you can ask them, why does this happen? Why isn't the interest increasing? And then they'll be able to tell you that, okay, the bank balance, it restores to 20,000 all the time you withdraw, so your balance isn't increasing. So you can add the words as well, language. You can say this is not compounding. So compounding is the idea that if you're combining collecting, and on top of that you're getting interest. So that you can also incorporate, what we do is we incorporate language into it. So whenever they have to explain something in English, they can include these mathematical terms into their vocabulary as well. So that's another plus point. So we look at this. So they get 26,000 here, but if you withdraw, they get 18,000. Now you put down the question, and you try to get to a conclusion. Why do you think banks use this? Right? Why do you think banks use this? I mean, so you should see that it's an incentive that, I mean, if you decide to withdraw every year, you only get 18,000, but if you keep it, you get more and more. So it's a win-win for both investor and the bank, and that's I think this is a wonderful practical example that students can relate to. And it's also, I've seen that they get more engaged when you use the simulation because they like to change the numbers, look how things work, compare, share their own ideas, and it's wonderful. And this also, we've seen that it transfers to discussions in real life as well. They talk with their family and they share what they've learned. They talk with friends and share what they've learned. beyond just the calculation. Previously, it was just a formula for them to calculate compound interest. They just put it into a formula and then calculate the value. But now you put a nice scenario, a real life scenario that they can relate to. You put them in a playground as such, so they can change the numbers, and you also get them to predict, to engage. So this really isn't going to give students the whole idea that we use simulations at Cloud Linux is not to teach a concept, not to teach a concept. But once we've taught a concept, if we want to give them a deeper understanding, right, and then test the critical thinking, or get them to think more deeper into the concept beyond calculation, that's when we use simulation. Allow them to explore. And generally you see, like, when you use this and go beyond like a normal session, it's more engaging. They get more motivated to learn math, and they see the real value behind this. um, yeah so if you also want your child or student to have personalized sessions, if you want them to develop critical thinking skills, that's very useful. If they are pursuing, not just if they're pursuing a career in related to math or STEM, even for real life, these concepts is all about helping the student use the knowledge that they gained beyond just that exam question paper. They are able to see how this is applied in real world. They can use these skills in real world. That's what we're trying to help them with. So if you want your student to gain that, and you think they're lacking in that area, you could get them to join Cloud Linux. We deliver personalized lessons, one-to-one sessions online, and you're gonna see a huge change in math education from uh, from us, and we're trying to do our level best to meet the international standards of education and of teaching math. All right, so reach out to us on our FB page or on WhatsApp, and we'll be glad to help you out with anything. Right then, until the next video, I'll see you again.